The decay of a neutron at rest would require momentum conservation. And so your initial momentum, P naught or Pn or whatever, will be 0. You want that to equal your final momentum. So the sum of the three momenta, P sub E, momentum of electron, P sub P, momentum of proton, nu, momentum of neutrino, okay? So 0 is the sum of all of those. So consider, for example, that you want the momentum of the electron, okay, P sub E. And so that's equal to negative P sub P negative minus P sub nu. So it's the sum of the proton and the neutrino's momenta. And so you draw it out on you draw out the vectors. What you get is something like this. So you have let's call this P sub P. So that's the momentum vector of the proton. Let's call this P sub this right here, P sub nu, momentum vector of the neutrino. And so this equation states that P sub E will just be the sum of those. So this line, but in the opposite direction. So that, P sub E. And so clearly they lie along the same plane. So they are coplanar. And you can replace PE with any of the other two. So you can do this for P sub P. You'll get the same fact that that momentum will be a sum, be the negative of the sum of the other two. Same for P sub nu. And you can draw out the vectors, and it's going to be the same situation, the identical situation. So they all must lie along the same plane. And so they must be coplanar.